Hi, my name is Henry Brill. This is Show Your Work Video 5. I chose to do problem 6. I have that pulled up right here, and I already wrote down the series substitutions and their derivatives. Um, yeah, all right, so just like quick, so did the power rule for this, and then once again for this. Uh, yeah, so now we take our original equation and we substitute these series substitutions in for this. Yeah, so I'm gonna see if I could do something like this so I don't have to keep writing it. Oh yeah, awesome. Okay, so we have this. Wait, maybe I could actually. So we have this Command C. Okay, awesome. Great. So I don't have to keep writing it. Okay, with this, then we have this. Gotta make some room here. So you see from the equation, it's negative 5x. So negative 5x parentheses this, y prime, minus normal, just y, which is this. And I will use this tool again. Awesome. Okay, so now we have this, and the next step is to so actually go. So our goal, you see right here, find A0, A1, A2, A3, A4, and I have the answers here, but this is about showing your work, and this is a good way just to double check. Yeah. So A0 and A1 we are already given. So because we see y of 0 is 2. And if you were to plug into this equation right here where x is 0, then this would go to 0, this would go to 0, and all other terms after would go to 0. So we know y of 0 is just A0. And y of 0 is 2. So we know that this first one's 2. So let me write that down. A0 equals 2. A1, A2, A3, then A4. So these will be our goals for this video. Sweet. All right. So also we can find A1 because we have y prime of 0. So we took the derivative of this, right? This term's constant goes to 0. This just goes to A1, right? Because we get rid of the x according to the power rule. The x is 0, which is 1. So we just have A1. So if we write this, we got y prime. Little arrow. We got y prime equals A1, no x, plus A2 plus 2A2 x, and so on. Okay, so then using the same logic, y prime of 0, all these terms will cancel out because there's x's in them, but there's no x's here. So then we know y prime of 0 is 1, so A1 is 1. Boom. So that's already 2 of our answers down. Okay, but now we actually have to, work with because we don't have any more conditions. So All right, cool. Now that we have this substitution, we can just do some simplifying first. So x n to the negative 1 can be written as x to the n times x to the negative 1. Because of power rules and stuff. So now, since there's no n here, or in this term right here, we can kind of just bring it out front, in front of the summation. So it'll look something like this. And then I'll use my tool. Like that. Right around here. So this is what we have now for this middle term. And you can see that this x will cancel out. So we could just simplify it to -5, and then this, and then, sorry, we need the x to the n. So this, move this over, -5, and then we have our x to the n, because that cell is the n, so we can't, move it to the front. And then now we have, and then now we lasso all this. So that was just the first thing I wanted to do to clean some stuff up. Wait, actually, I want to keep my work, so I'll do that. Oh, wait, I can just do that. That's great. Okay, cool. Boom. Now this is what we have. And it's equals 0. So let me add that real quick. Boom. Alrighty. So now we have to re-index. So yeah, we can make everything work. So I guess for this, you see, we got to get everything to have 2. I don't know where the equal sign here went. Okay. So I guess what I'm going to do is we want to get it to 2. So I'll just make this little condition. Let m equal n minus 2. And then this therefore means that like n is m plus 2. So now we can substitute in for m and n. So yeah, I guess the first thing we want to do is play this where we're going to plug in the n term. And here, I'm just trying to see what would be the best way of going about this here. So okay, so I guess the first thing that we could, all right, I guess we go with this. What we could do is plugging the n1 and n2 terms in, we get this, we're going to re-index this to where we get n plus 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . n plus, because if we plug in n plus 2, right, n turns into n plus 2, n minus 1 turns into n plus 1. So this is just where we're plugging in n plus 2. That's what we're going to say. So then a n plus 2, and then just x to the n. And then it would be 0. So just like that. Then this would be the same for now. Wait, how did I? This would just be the same. And then this was just, because it already has 0. Just make this the same. So boom. All right, cool. So now we have to collect and regroup out the powers of x. Yeah. So, and then actually set n equal to 0. Yeah, cool. So what? Oops. All right, so like I was saying, we're going to plug in 0, but I just wanted to quickly explain why we don't make this 0. We don't make this 0 because the 0th index or whatever would just be 0. So there's no point in having it at 0. We might as well start it at 1 because this would be 0, and anything from 0 is 0. So we might as well just start it at 1. So let's just say, let's let n equal 0. This gets us, we have 2 times 1, and then a2, a sub 2, and then this is 1, because anything with 0th power is 1. This whole middle term, like we just discussed, is 0. And then this would be just an, because, it's 1 times an, so minus an, a sub n. All right, cool. And one thing we have to keep in mind is that we can plug in our, or wait, no, this would be a of 0. That's what, okay, that's what, yeah, I was thinking. So this would be a of 0, right? And one thing we can keep in mind is that we know our, this all equals 0 because, our whole system, we it equals 0. The question says equals 0. And we can plug in our, a0 equals 2. So that's what we have to keep in mind. So this is just 2a2 equals 0. So then we know a2 is just negative 1. Or, sorry, 1, positive 1. Because, add 2 to both sides and divide by 2. So, boom. Now that we got that, okay, now we can here. So now we could add this to our answers. So a2, also 1. Okay, now for a3. Let n equal 1. All right, so go back up here. Letting n equal 1, we got 3, 2, then it would be a3 because it's an plus 2. sub n plus 2. So 3 is 3. Minus 5 times 1, a1, and then equals 0. So now we can, solve for a3. We can plug in a1 because we know it is 1. So that gives us 6a3. 6a3 and then minus 5a1. And we know a1's 1, so that's just 5 equals 0. Oh, wait, sorry. And then I almost forgot. We also have this right here. So this would just be 1. So it would be a1 because, yeah. Cool. And, oh, sorry, I should mention, this is after we factored all the x to the n's out. So I should, I could rewrite it. Yeah. Our x to the n's are factored out currently. So we can ignore these when we're plugging this in. But yeah, so this is also just minus 1. So, and then we know this is 1, so it would be equals 6. So then a3 is also 1. Boom. All right, so add that. Check our answer. Yeah, cool. Okay, now we have to find a4. So, a4 is a little bit different. So, okay. What we have to do here is take our original, like this right here, our n plus 2, n plus 1, a n plus 2, minus minus 5n, an, minus an. So here, I'll rewrite that. So, boom. All right. This is just when we factor xn out, x to the n out. Just remember that. So now we have to solve for our, just general a then term, or I guess in this case it would be an plus 2. So, all right. We do that by first adding both of these to the other side. So we would get equals this, and then we would divide both sides by n plus 2, n plus 1. So that equals an plus 2. Boom. Alrighty. So now that we have this, we can make we want to find the a sub 4 term, right? So we would plug in, we would let n equal 2. So because this should be 4, n plus 2 we want to be 4. So then we get a of 4. Sorry, my friend just texted me. Okay, so now A4, we'll plug into n. So we have, remember n is 2. That's what we're working towards here. All right, so 5 times 2, 10, times a sub 2, which we can go back up to our answers, we know is 1. Yeah, a sub 2 is 1. Plus a sub 2 yet again. So that's also 1. Boom. Over 2 plus 2, 4. And then n plus 1 is 3. So this will then go to 10 plus 1, 11 over 3. 4 times 3 is 12. So boom, 11 over 12. And that is that. Awesome. Well, that is it, and thank you.